All right, welcome back, everybody. We're going to do what we can to finish off this 5150 amp today. Last time we recapped the main board, changed out all the electrolytic caps, including the small signal guys. Today we're going to start, before putting this board back in, we're going to go ahead and clean the pots. And then I'm also going to flip it over and just touch up the solder joints for the jacks and all of the pots. Anything that has a mechanical, physical connection to the front of the amp usually gets some amount of strain. And I'm not saying that any of these are bad necessarily, but while we have it open, it takes just a couple minutes to touch up these solder joints, make sure that there's no cracks, or if there are any hairline cracks in the solder joints, we can just go ahead and prevent that from being an issue when we get it back together. Just a couple notes on cleaning the pots here. So these guys, we can probably spray in through the top here. There's a little bit of an opening. Sorry about the glare from the light there. But also could go from, it's going to be a little hard to see, but we can get on the back side of these guys to get into the opening of the pot there. The one thing I recommend avoiding, let me know if anybody out there has had a good experience with these, but they make these caps that screw onto the top of the potentiometer, or will like set in place on top of there, and then you're able to then like take your deoxit or your fader lube and spray in and force the cleaner in through this gasket. I have never had a good experience with those before. If you have, I am curious about that. I tried one out once and it just did not seem like a good way to go. So yeah, just a thought I had. So let me know what you think of those. Otherwise, we're going to jump in here, clean the pots. Again, I'm using actual fader lube, not deoxit D5. Deoxit D5 you would use if you have a really, really scratchy pot that you need to like clean out debris from, and then you would still follow up with some kind of fader lubricant. These were not known to be bad or anything, so I'm just going to give them a quick clean since we have the amp open. And then we will do some soldering, and then I'll grab the rest of the amp and we'll see what else there is to do. Okay, so this may not be too exciting, but just going to put the tiniest little spurt of this stuff in through these top openings, and then give each of the pots a good back and forth, and we'll work our way through here. It really does not take much at all. Even the amount that's coming out there is probably too much. And doing this preemptively just kind of prevents the possibility that one of these is super scratchy and we're going to have to open the chassis back up or something later on. It's always good to only fix what needs to be fixed if that's what the customer wants on an amp. But again, this is my own amp, so it's a little bit easier to just give it the full overhaul while I have it open. Or if a customer asked for that, if they were going out on tour and just said, hey, here's my budget, give it a full overhaul to make it as reliable as possible, I would obviously discuss what that means with the customer from my perspective, to make sure that we're on the same page and everybody's going to walk away happy. But yeah, in my mind that includes cleaning the pots, touched up solder joints that would be prone to stress, making sure everything's going to be operational and reliable, and then addressing any problems as they come up. Make sure there's nothing that's going to fail in the foreseeable future, so that nothing happens when you're out on the road, at least nothing that could have been found or prevented easily. during that time. And with that in mind, I've actually been lucky enough to never have an amp fail on me during a show or a tour for my personal use. I did have one during recording. My Ampeg V4 decided to start red plating, and we left it on long enough to grab a picture of the tubes shooting lightning bolts so you can see the electrons shooting across them. And man, they were glowing so red, looked like lava. Okay, so let's touch up some solder joints here. Yeah, so we got a picture of that, threw a fan on it, popped the fuse. I was able to find another fuse, but we did have a full day of recording planned for that day, so luckily it seemed to be just fine. It was just a failing tube. It wasn't a coupling cap. So we're able to get through the recording and throw some new tubes in and move on. Okay, just waiting for the soldering iron to come up to temp. I have actually two Ampeg V4s that will need caps and an overhaul. One a V4B, the other the normal V4 that has the reverb on it. And we'll definitely need to overhaul those on the channel. People seem to not like doing them because a couple of the capacitor values are not easy to get. You can pay for a cap kit from a website called Flip Tops, but you can also do something similar on your own. There's also SNK pedals that makes the VHT pedal, which is a really cool distortion pedal. They have a circuit board that I actually bought a couple that allows you to use just like normal can caps that you can buy from Mouser or DigiKey for the Ampeg V4. Sorry, this is a 5150 video and I'm just talking about Ampeg V4s. But I think you have to drill into the chassis for those. And that's not something I really wanted to do. I think even, I could be wrong about this. So again, if someone knows better without me double checking the instructions I got, I believe it even said on the website that there's no modifications needed or no permanent ones. And then when I got the actual boards, it had you drilling out a couple holes in the chassis to accommodate for the new PCB, which is fine if that's the route you want to go, but that is not really what I want to do. I would prefer to keep mine original and just go ahead and put the extra work into finding the right capacitor values. And of course, I'm saying that while not actually doing that work. So by the time I get there, I may change my mind on that. But those really are great amps. So 4 of these pins on these pots are just to mechanically hold the potentiometer in place for some strain relief. That's these outer 4 guys. You can see that there's no PCB track to them. But I'm just going to touch them all up anyway. Over here. Honestly, if I had a little more time, I would probably just go through and touch up all the solder joints on this board since it's out. That's one of those things, if you're really having trouble with an amp, with troubleshooting, and you have the time, you can just go through and resolder every joint. Just make sure you're not adding excessive solder, because that can be problematic too. You can easily get a cold joint and not know it. I'm just barely adding anything to these, and really even just heating them up, if there was a cracked solder joint, would be typically enough to solve that. Let's see. But usually if I'm, especially a working or a gigging amp, something that's not just been sitting in a studio and been treated very well, if I'm opening it up to this level, may as well reflow some solder. So I believe I mentioned this in the last video too, but after this guy, we're going to have a couple customer amps, and then actually have two VTM 60s for the Peavey crew out there. I managed to acquire a second one in the time since I made that first video evaluating the one I had before. And the fun part is that second one came from a guy that was in a band with the guy that I got this 5150 from. So those amps are brothers. So big shout out to Alex Frank and Envision for the VTM 60. Okay. Might even, looks like we got a broken solder joint right there. Look at that. Can you see that leg wiggling? I'm going to go ahead and touch that up. What's this one? No wiggle. No wiggle. Go ahead and inspect these other solder joints. These ones always look funny, but it's because they're the terminal. So these are actually good. It's just, it's a funny look since they, compared to a normal solder joint, because they have a pin going in there. I think everything else looks good, but yeah, glad I caught that. Okay. Let's touch that guy up. That's good enough. Okay, I'm going to grab the rest of the amp. We're going to, I think, go ahead and replace all the small signal electrolytics on the preamp board as well. Yeah, let's check that out. Okay, so a little bit of a toss-up here because we could pull this board. You can see I actually stole a tube from this at some point when I needed it for a different amp. We could pull this board and leave these connectors in place. We would have to disconnect this one, either from here or from here, the red guy. And then take this back panel off, and then there's 4 screws going into little riveted terminal kind of guys here. However, all we're replacing are these 4 electrolytic caps, which all are pretty dang accessible from this back side. So the question is, do I pull the board to do that, or do I remove these connectors to instead just solder it with the board in place? Now, I think I would rather give you guys a cool view of this board, so I think I'm going to do it the long way, but just as a heads up, if you were on a time crunch and needed to do this same thing for some reason, you could do so without actually pulling that board. Okay, so let's go ahead and pull the board out, though. Okay, so we will need to remove this guy, and we'll probably need to remove these all these connectors anyway, actually, to get to the solder joints. Now, this red one only has a single wire, and that's going to the bottom connector as this sits. Saying that to tell you, but also to tell myself in the future. Be careful with these boards. The only thing keeping this board from flexing is this little rubber stopper here. So you definitely want to use some amount of finesse. But unfortunately, the solder joint, the PCB connector, is directly underneath there. So let's see. Also, always be careful with these ribbon cables. They only have so much flex in them. You can see this one's gotten some heat or something at some point. But they are one of the more fragile parts of an amp somehow. These internal wires can crack from flexing them back and forth too many times. And it's can be hard to diagnose if you don't know to look for it, because they are not directly visible. So you can have a bad connection that's there, but you can't necessarily see it. That's a thing on like Fender hot rods and things like that as well. Just a good thing to be aware of. And let's get a good screwdriver here. So we've got this back panel. This is how you would normally, with the amp in the chassis, would be able to access the preamp tubes. I'll probably go ahead and test these tubes as well to see if any are worth keeping in this amp, or if I should put some new tubes in there. I'm pretty sure this guy is going to come live down my practice space for a little bit. So, might be worth having some new tubes. Eddie Van Halen signature. I must be a Peavey authorized service center. I'm not really, but here we are. If anyone from Peavey is watching and wants to give me a call, let me know how to go about becoming an authorized service center. Happy to take a test or whatever. Okay, so just 4 more small screws here. This will be good because we can go ahead and touch up some other solder joints like the tube sockets. When I have the option to, I prefer to solder in a way where gravity is going to aid in the construction of a good solder joint, meaning the solder is not going to flow at an angle or something like that as it's cooling down. Definitely been in scenarios where that was not an option. Working on hydraulics and things like that. Oh, here's a little piece of rubber from our stopper. That's interesting. Guess we'll put that back there. That might be some kind of insulator. Okay, here's the bottom of our preamp board. Look at that. Seems like it would be a cool thing to throw in a pedal. Just saying. Oh, hidden cap. Look at that. 47 microfarad, 50 volt. I think I got one of these. So we can replace that too. I don't think I caught that when I was ordering parts because it was hidden behind this tube. Okay, cool. And I'm going to go ahead and put this chassis behind me so we can get to work on the preamp board. All right, I was able to find a 47 microfarad, 50 volts, 47 mu-F, as some people pointed out in the comments on the last video. I have opinions about this. They are right. That is a mu symbol, not a U. But in my close to 2 decades of working on this stuff here in America, we say a lot of things incorrectly. Everyone says UF. It's just easier. We don't have a mu key on our keyboards. If you Google capacitor UF, you're going to get microfarad. So, you know, that's what it is. I will apologize on behalf of all Americans for saying everything incorrectly. Although, yeah. Okay. So yeah, let's go ahead and remove these guys, and then we'll do this one. And that is like an old IC cap too. So, yeah, but good opportunity to clean these sockets while we're here. This 5150 is really getting the full treatment. All right. And you can see why we need to remove this connector. This leg, it's basically touching that connector. Is that blurry? Let's see if we can get that. So, would be a very tight fit. Okay. Go ahead and remove that. And let's see. You could also, for these kind of things, go ahead and just clip the component out, like clip the legs on the top here, and then just clean out the solder and the extra leg. We're not planning on keeping this component, so there's really no point in making sure that it survives. 22 microfarad. 25 volt. I believe we have some of those. Let's see, is that these guys? These ones are... Need a closer look. It's time to get some glasses. These are 1 microfarad, I believe. These could be for the VTM. I ordered the parts at the same time. Can't remember. 10 microfarad. Okay. So it must be these. .22 microfarad, 63 volts. Okay, that'll work. And we have our negative going to the right. From our perspective, let's see if we can get both the value and the negative symbol. All right, perfect. And then just the tiniest bit of solder on there. Doesn't take much. There's not a lot of weight on these components, so it's not like they're likely to fail from vibration. This board is relatively well supported. Okay. So let's move on to these guys. Now, what value are these guys? 1 UF, 50 volt, 1 UF, and we'll have to see on this guy when we pull it out. Oh, nope, 1 UF. I can just barely see it underneath there. Okay, so these three are 1 UF 50 volts, which I saw in my pile over here. Let's go ahead and take those out. Maybe we'll remove all three and then go from there. Need to give that guy some heat. Oh, there it goes. Okay. Just confirm the value. Yep. Okay, all three of those out. Grab our 1 UFs. Again, I'm using these Vichet. Forget the name of the series on these, but they're the blue guys. I do like these. And these are 1 microfarad, 63 volts, so we should be good. Try to get the value. Yeah, there we go. Trying to get the value and the line showing the orientation for the negative both visible to anyone opening this up. And the positives go this way for all three. Okay, so our negative stripe is pointing down for all three of those. We have a little bit of strain relief from the legs being bent over. Solder these up. Just giving an inspection. The solder joints for the tube sockets actually look pretty good. Not seeing any issues there. Okay, so let's get this other guy. Negative's going to go this way. 47 UF 50 volts. We've got the same here. I'm just going to orient this so it makes sense. That'll be these two. Now with these guys, it's sometimes easier to just... see if I can do this on camera. Yep. Give it a little heat. Wiggle it out. And I'm just pulling on the capacitor on the other side, which maybe can't see any of this, but... okay. There we go. Probably need to clean those out a little more.
Just a little better solder joint there. Not too happy with that guy. I'm going to redo this one. I think it got just a little too much solder on there. All right, I'll do it. Okay, let's clean the tube sockets here. And I mean, since we're out of the board, I'm just going to blast these guys. I don't like doing that in amp since it makes such a big mess. And then we'll take a tube. Another thing we could do that I've seen people do, I've never actually done it myself for these kind of tube sockets. You just blast them with isopropyl alcohol, let them drip out. Pretty sure I've seen Psionic Audio do that, which makes sense. You're basically just trying to get any kind of dirt or crud out of there. Make sure there's a good electrical connection between the pins. Maybe not quite as much of a problem for newer amps. Now that there's no smoking in bars, the amount of just like residue on an old like Fender or something like that can really be pretty gnarly. I really don't know how people that sang in bands did it back in the day. Okay, that looks pretty good. Let's get this back together. Then I will test some tubes, and probably will be good to fire it up on the current limiter. See if I put anything in backwards. All right, let's get the chassis back up here. Okay, so we'll put our preamp board back in first. Gonna hold off on putting the actual tubes in. Let's see, this must sit like that. In the meantime, I will think if there's anything else I want to do to this before we fire it up. Probably will clean the jacks, these guys. Give a quick inspection of the power tube board. Trying to remember what was even going on with this other than it being noisy. Which, I mean, a 5150 is always... They have a pretty high noise floor, even when working well with the stock circuit. But I think... Oh, did I put that in upside down? God dang it. Okay. I'm leaving that in so you don't do the same thing. If anyone caught that while I was doing it, you get bonus points. A little bit under the weather today, so the brain is moving slightly slower. All right, this makes more sense. That would be a revision 1 thing on a circuit board if I were making this. Do not make the board holes symmetrical. If the distance between these is different on both sides, that is a mistake you want to be able to make. Really is not a mistake most people will probably make, but I made it just now, so. And let's see. Better to put a PCB in backwards and catch it right away than put a filter cap in backwards and have it sound like a shotgun going off next to your head. As the old saying goes. Those are good. This guy goes back in with the only wire being on the bottom. Okay. Get these connectors back in. Make sure you're not off by a tooth when you're doing these. I've done that not in an amp, but in other devices. And it's can be a catastrophic mistake. Okay, time to grab the main board. Get that back in. I'm going to leave the cover off until we test the tubes. Yeah, just looking around to see what else we can do in here, but I think we've kind of done it all. All right, we'll zoom out a little bit here. All right, main board coming back in to wiggle into place. Let's see, this goes this way. It was a little bit of a hassle to get out. We had to go like this. Okay. Let's do this a different way. Let's go ahead and take these all back off. Gives us slightly more wiggle room to come in. Sorry for the turbulence there. Okay, this is one of those things we're getting all the all the potentiometers and the LEDs and the buttons aligned. Be a little bit of a headache, but we got there. So I'm going to go ahead and get this board loosely in place. Securing the pots on a couple sides. Just finger tight. Then we'll go ahead and screw the actual PCB into place. Make sure everything's seated correctly. Okay, that's all good. Connect some connectors. Check my photos here in a minute to verify that these are all going in the correct way. And then what we will do is power this up with no tubes on the current limiter. Anytime I've done filter capacitors or any work in the power supply, it's always a power up on the current limiter for that initial power up. Just to make sure nothing is put in backwards, there's no short circuits. Once that is verified, come off the current limiter, measure voltages, make sure everything's good, then put tubes in. Sometimes even then, again, with the current limiter, I may even do that this time because of the extent of the work that was done. and then test for sound. If everything is good, everything seems stable, we then come off the current limiter full power with tubes, see what's going on. Okay, so at this point, I'm not even going to finish securing all of the pots to the front, just because there is a chance we're going to have to open this back up if there is an issue at this point. Before that, though, before we power up, I'm going to clean the jacks, the input jacks, as well as the effects loop. People with these amps often have a problem where the sound's cutting in and out and it's getting weird, and they solve it by putting a cable just connecting directly to the effects loop. That's kind of a short-term solution for just cleaning the jacks or replacing the jacks if needed. So we will go ahead and clean those real quick. A little bit of deoxit sprayed in there with the jack going in and out. And then we'll test our tubes, and then we'll do our initial power up. See what happens. All right, right back with you. It's obviously been a while since I played one of these, because this is actually the effects loop over here. I was pointing at these guys. These are the main speaker outs. So I'm just going to take a patch cable over the garbage can. I'm going to spray some Deoxit D5 on there, and then plug in out. Try to clean these jacks up a bit. So again, one of those things you can, a little bit goes a long way. These Peavey jacks are a funny, like, 5-way connector. So you can't just necessarily throw in like a normal stereo or mono jack for them without some modification. Okay, let's get the input jacks. All right, that should be okay. And while that residue is drying, I'm going to go test some tubes off camera, and then we'll be back in just a moment. Okay, so 3 of them tested totally good for the preamp. This guy tested to be extremely gassy, meaning it has a gas leak or partial vacuum leak. Which, you know, by all accounts, this looks like a good tube. So, kind of glad that I threw that on the tube tester. I've seen a lot of people online lately posting pictures of their tubes and saying, do these look good? You really can't tell just by looking at a tube. All you can really tell from looking at a tube is whether the filaments are working or if it has catastrophically failed. If there's like white, powdery looking stuff all over the inside, then that's a catastrophic vacuum leak failure. If it's not lighting up at all, then you probably have a problem with your heater circuit. But beyond that, you can't tell. You can't definitively tell that a tube is good. Same with a tube tester like I use, one of these old school ones. It can't definitively tell you that a tube is good. It can only tell you if it is bad in certain ways. So this guy's going to go in the bin. I might hold on to it just as an example of a gassy tube. But I'm going to put the other 3 back in. They tested good for life and everything. Now, I could put them in there and they still don't sound right. The ultimate test of whether a tube is good is how it sounds in an amp. This is the ultimate tube tester. The only reason I test on my circuit is to catch, or on my tube tester, is to catch things that are definitively bad to help save time with that and to not risk damaging an amp any further by putting it in there and then testing it. So, throw these in, throw in 2 more let's see, these are 12AX7s, ECC 83s, and then some power tubes. I think I have tubes that were in this. I'll put those on the tester as well, and then either put those back in or put in a new set or one of my used sets from another amp that are still good enough to go in this amp. And then we'll do our power up with no tubes and see how it goes. All right, here we go. Ready for an initial power up. No tubes installed. Power tubes tested great. They're like brand new. I think what happened was I retubed this amp at some point, and was using it for my metal band, and then decided to not use it after it had some issues that I didn't have time to address at the time. So that's great. I ended up cleaning the power tube sockets. I did that off camera, so apologies for that, but pretty similar to what we did for over here on the preamp tubes. We are hooked up into my attenuator / dummy load, going to a speaker cabinet. We have no tubes installed, going into the current limiter, or light bulb limiters, they're sometimes called. We're going to do an initial power up, check for voltages, make sure that there's bias at the power tubes, make sure that there's plate voltage at the power tubes, and as best we can, test at the preamp tubes as well. This is one benefit to leaving those out for now, so we can just test directly in the pins, because getting underneath here is a little bit problematic. Yeah, I don't think there's anything else to double check before we get going on that. Let's see. Final thoughts here before hitting the power, but I think we're good to go. So let's see what happens. Oh, and did we... Nope, we're powered on. Okay. I thought I heard something in there that sounded like a click. And I apologize, my head keeps hitting the camera there. Okay, I believe we are powered up, but let's see what happens when we check for voltage. And we should be able to grab a ground off of this plate here. And we're measuring DC voltage. Let's see what we got. Are we getting anything? Or is this not a good ground connection? Not a good ground connection. Okay. Let me grab a better ground here that we can get from somewhere. May connect this here. You guys can still see that voltage. Okay, so this was a bad ground. This might be aluminum or something. Okay, we're getting bias voltage there. Again, these voltages are all going to be lower because we're on the current limiter. And this is kind of funny because they're lower in some ways, but then they're going to be a little bit higher because we're unloaded. And... oh, little earthquake there. Now this is funny because I forgot about this, but this tube is hard to get to. We're going to have to flip the chassis over to measure what's going on at that guy. Okay, there's our plate. We have that there too. Yep. Okay, what else should we measure? Plates for the preamp tubes. There we go. Pin 1, pin 6. Okay, so channel selects are working. Okay, so I think we're good at this point to throw some tubes in, keep it on the current limiter, and then see what happens. Okay, we're powering back on, still on the current limiter, but now with tubes. And let's see if we get any sound out of this thing. Oh, and it sounds like we had sound for a sec, but something popped. But we still have power. Okay, gonna need to investigate further what's going on here. All right, so I believe I have found the issue, although there may still be another issue once we get this fixed. These 3 capacitors. 1 microfarad. I think they were 50 volt. Let's see. Yeah, 50 volt. These looked and appeared to be, I'm trying to find one of the old ones so I can show you, but they appear to be electrolytic caps. However, upon closer investigation, they are non-polarized electrolytic caps in the schematic, which means they don't have a positive and a negative side that can go in either way. Now, I didn't catch that. I got the value for these just by looking at the actual capacitor. I didn't catch the NP because it was kind of hard to see, which means non-polarized. And these need to be non-polarized caps or have the correct arrangement. They don't technically need to be non-polarized caps. We can put electrolytics in there. However, if we're doing so, we need to be more conscious of the orientation. On the caps that I put in, they had the indentation in the negative side the same as what I put in here, positive on this side, negative on the other. However, according to the schematic, the positive side of this needs to go to, let's see, it's pin 8. This guy is C3. Should go to pin 8 of this socket, and instead it's the wrong way around. I need to flip the polarity of these. So C3 positive goes to pin 8 and negative goes to ground. This is, you can see here, this is our ground plane here, which I should have caught as I was doing this. So that should be the negative side for all three of these. And then the positive side will go for C3, which is this one, will go to pin 8 of this guy. This one, the positive side, will go to, let's see, it's pin 3. And then these are basically the bypass caps. So it's just going to the cathode side of both sides of this triode and then one side of this triode. And we can prove that with our multimeter here, doing a continuity check. So this side, let's see, pin 8, it's right there. Whereas the positive that should go there does not. And same on this. Pin 3, nothing. Pin 3, there it is. And then again, pin 8 for this one, nothing. Oh, is it this one? Let's see. C3, C4, C5. No, it is pin 3 on this. It goes to the second stage. There we go. So need to swap those around. This guy should be totally fine, but we'll double check it since I'm in here. This one was also polarized, so it should be fine. But again, we'll double check since I have this board back out. And that should fix it. Now, how did I figure out this was the case? The issue we were having with the amp was that it was making sound, and then after things turned on, all the sound disappeared completely. I then plugged the guitar into the return of the effects loop, and there was some sound coming out. So we knew it was in the preamp side. Usually when you have some sound and then it just totally disappears like that, can be an indication that there's a capacitor that's going bad, or that is the wrong polarity, but is not getting enough voltage across it that it's going to blow up. Because basically what's happening is once the capacitor charges up all the way on its plates, it then acts as an open circuit. In this case, it was basically cutting all of our gain for our preamp tubes, because we had essentially a short circuit around our resistors that are setting the gain on the cathodes of those tube stages. So no signal was making it through. Okay, I'm going to swap these around, get this board back in, and then we'll give it another test, see what happens. Okay, so capacitors have been swapped on the preamp side. Let's go ahead and power this guy back up. See if there's any other issues at this point. So still on the current limiter, we now have tubes in going through the attenuator / load box. Everything should be good, but also should have been good the first time. So we'll see. Could still be something going on. Channels are switching. We got some sound. And still a similar issue. Okay, gonna power down. All right, we've got a working amp finally. Let's see. We'll have to do a full sound check on this guy until you guys hear what it sounds like. Had a couple issues going on. There was the non-polarized capacitor thing in the preamp, which was cutting out the sound completely. And then once I did get it on full power, noticed the bias was way too hot. I was sitting at something like negative 17 volts or so. Now it is at, let's see, we're reading negative 57 volts at the bias point here, and the output of the bias circuit, negative 59 there. This resistor that I changed out in the first one of these videos when I was doing this late at night, it's supposed to be 15K. I even extensively talked about how that should be a 15K resistor. I mean, I should put in a 1.5K. Learn from my mistakes, double check. I'm pretty sure I even checked that with the multimeter and just ignored that decimal point because I was a little tired when I was doing this before. So please don't make the same mistake I did. A couple good lessons in here. Polarized caps in the preamp can replace with electrolytics, but check the polarity, since the ones that are in there may not have the correct polarity compared to what you need. And then double check your resistors. Can happen to the best of us. Make sure if you're putting in a 1.5K, it's actually a 1.5K. Don't want to fry your tubes because of a bias issue. Okay, so I'm going to get this all back together. That's going to do it for this video. We're going to be back with the Peaveys on some VTM 60s. Going to have a couple, probably a couple Fender customer amps, maybe a Marshall customer amp in here for the next couple videos. And then we'll be back into the Peavey landscape with those VTMs. I actually preemptively bought capacitors to change out on both VTM 60s that I have lined up. So we're going to do both of them. All right. As always, thanks for watching. Sorry for the delay on this 5150, but this guy is back, ready to go to a band practice and, yeah, get real loud, real crunchy, and have a good time. All right. Have a good evening. We'll see you on the next one.